Thank you so much, Kevin, for getting me introduced with the audience we have here at Summit. So, yeah, hello everyone. Like I'm Part Sony, and it's great to be here at Summit. And let's get started with the insights. So, first of all, just a quick question to let us get accustomed. Okay, like. Have you ever in one of my experience, so as because I'm here to share the practical insights on many experience where I use Apache Doris on different architectures. So when I look back at our cloud infrastructure bills and thought, so I thought, like, did we accidentally start mining a cryptocurrency? Funny, yeah. But turns out we are just running analytics in a very expensive manner, right? So today I'm going to show you how I transformed our large architectures, analytic infrastructures, costing dramatically high while improving the performance. And yeah, that's how we use the Apache Doris here. Okay, so over the next 30 minutes, I'm going to explain you different architectures where I utilize the Apache Doris and how it helped in different architecture with the different use cases. Yes, and I promise at least one of this will make you think, why didn't we think of this at earlier, right? So yeah, let's dive in. Okay, so as Kevin introduced me, we are directly jumping to the architecture first. Okay, so I'll keep this faster because keeping in mind the constraint that we are having. Okay, so first architecture that I'm going to present now is the AI native real-time feature store. Okay, and I would like to call it like how to make your feature store actually affordable, right? So yeah, so here is the problem. You are building a ML model and you need a features, right? Fresh features like sub-second freshes. Have you? Is there a traditional approach? Yeah, use the manage key value stores, right? Yeah, and it works, right? But until you realize that you are paying a premium prices just to remember what a user clicked 5 seconds ago, right? So we were spending significant budget on the managed databases on the real-time feature stores. Then back in the time when I started my first POC with Apache Doris, that was migration from Snowflake to Apache Doris. I get to know a lot of features, like what else we can go with Apache Doris, right? So yes, so here how I implemented it. Okay, so first of all, Kinesis stream pour data into the Doris at high throughput. Uh, I am utilizing the primary key tables with upserts, which handles the real-time updates seamlessly. The one of the major key point I used here was the materialized view, right? And with the heavy feature engineering automatically, right? So what it does afterwards, it SageMaker pulls the feature for inference in under 5 milliseconds. Okay, so here we have the whole flow here. This is how the partitioning I'm using it to make sure that I have the very fast driven queries here, feature management versioning here as well, right? Now the main thing is the secret sauce here is like Doris's columnar storage means we are only reading the columns we need, okay, not the whole record. It's incredibly efficient. So in production, just imagine we have 1 million features per second, 50,000 concurrent model predictions, sub 5 milliseconds latency, and drastically we reduce the operational cost here. Okay, so on a high level note, what are the key notions we achieved here by using Doris here between our real time data stream that is coming from Kinesis and the AWS SageMaker? We put a whole Doris core here. Okay, so for example, sub-second feature freshness using the Doris primary key tables, materialized view for pre-aggregated feature engineering, point queries with the millisecond latencies for online references, and yeah, time travel queries for training data consistencies, right? So this is one of the kind of a very very putting uh, the catch is I'm here, I'm not only using the Doris in a traditional way, but I'm also putting the data and AI alongside with it, and the AWS services, like how we can get the best out of it. Okay. So yes, this is one of the first architecture. I'm saving time for the big architecture that is going to come as we have the time constraint. But yes, we can address the questions at the later. Great. So this is the big architecture, and I can say this big architecture consists of the like two architecture within itself. We have the small pieces of work in here. So the main thing is, this is one of my favorite, and it's a short showstopper in my experience. How it is, okay? So that this architecture made our entire operation team actually thank engineering. Okay, so this is the like AI powered intelligent log analytics platform, and we call it as like enterprise log analytics. And let me tell you a story on based upon this. Okay, 6 months ago, our enterprise log analytics solution was costing us like more per month than some of our engineering's like features and everything, right? So we are talking about like how to reduce bills and everything, right? Now we found an alternative way, and I realized like Doris has inverted indexes, right? And Doris can do full text search at massive scale. Doris can ingest a millions event per second, and Doris infrastructure costs are dramatically lower. I got to know all this when I was doing my migrations from Snowflake to Doris in one of my first experience, right? Now in here, if you see like how it works, right? So we build this, we supercharge with it AI, because it's 2025 and AI should make our operations smarter, not just our products, right? So that's how we integrated the AI in the logs as well, right? So here is the architecture. We have the different log sources here, log stream from everywhere, applications, CloudTrail, infrastructure, security events, Kinesis ingest in 5 million logs per second peak, Lambda functions enrich each log with AI powered analysis. Uh, if I would say how this Lambda functions is using it, I'll just explain whenever the flow reaches here. And Doris stored everything with the inverted index for sub-second full text searches, right? So we get all the logs from here, from the Kinesis data stream. We get it in the Doris, and we have like auto schema detections, right? Now the thing is like how I was enriching the logs here, right? Now I would say just write a Lambda function that extract the entities from SageMaker, from the different log entries. Then we have like generate embedding from the bedrock. Then we have calculate the anomaly from the different historical baselines. Then we have the find of pattern, something like functions that you can write. And the main thing is auto tagging or tag, because based upon the tag, you will be create some good logging and dashboards kind of thing for the pattern analyze and everything, right? Now this part really get interesting. You know why? Because we integrated the Amazon Bedrock, that is like AWS Gen AI service. And let me show you how what features this enables, right? When it combines with the Doris, right? So just imagine, our operations team doesn't write complex queries syntax anymore. Like we have our BAs, we have some business facing persons, okay, who don't know SQL very well or cannot write a complex SQL syntax, right? So they what this helps us, like they just type in natural language, like for example, show me failed authentication attempts from the Asia Pacific last week. That is one of the example. Find all 500 errors related to the payment services. What happened around 2 p.m. yesterday when response was spiked, right? And Bedrock translate this from here, from here using the natural log search pattern and into the optimized sequels. Doris executes it. They get answers under within a seconds, right? And that simply lands, okay, to the user. No more complex query, language training, no more syntax errors. Just ask the question like you are using like you are asking to the colleague, right? So that is one of the unique feature that we have, intelligent log parsing, right? Now, the second feature that this delivers is automatic pattern discovery, right? This is where machine learning really shines. Okay, system uses like clustering algorithm, identify similar log patterns automatically, then Bedrock generates human readable descriptions. So instead of saying error code 502 occurred 15,000 times in last hour, you will see like database connection, pool exhaustion affecting the checkout service, started at this timestamp UTC, impacted approximate 1200 user sessions, similar to the incident from last month, where increasing pool size resolve the issue, right? This sounds very much unstable, instead of the error that traditional errors that we used to see, right? To find out exactly what meaning it is saying, right? So here, like, this is where AI is making things easier when you exactly put in the correct direction, right? So it's not just telling you what happened, it's telling you why, who was affected, and what worked before, right? And it's like having a senior SRE engineer with the perfect memory analyzing the incident. It's kind of work like that only, right? That is one of the feature. Third feature is like predictive alerting. Okay, so this feature has literally prevented many outages. The system learns what normal baseline behavior looks like, then it uses anomaly detection to spot the problem before they cascade. We got an alert once that said 85 probability of service degradation in next 12 minutes. Okay, so that's where your team gets prepared. Like, before the outage occurs, your team will start looking into it, what is causing it, to prevent the outage, right? Based on like it's exponentially increasing error rates in dependency chain, right? So that's how predictive alerting works, right? For an instance, we had like 12 minutes to investigate and fix it, right? We found a misconfigured deployment that was slowly exhausting resources. We rolled it back, crisis averted before the customer even noticed, right? And that is the perfect use of predictive alerting, how you can prevent outages. So that's the third feature we got out of this great architecture. The fourth one is like root cause analysis assistant, right? Now, whenever there are kind of some errors and outages, right? Everyone and executive people are more focused on the RCAs, like what exactly happened, something like that. So when incidents do happen, the system helps with the post-mortem analysis. It correlates the event across services, identifies the probable root cause, and even links to the similar past incidents. Like, yeah, in past this happened this, and this was a resolution, something like that. So AWS Bedrock analyzes the temporal correlation between the events and generates the investigation starting from points like upstream service latency increased from 200 milliseconds at this timestamp, cascading to the downstream timestamp at this timestamp, right? That is a kind of a response we get from the Bedrock. Great. So now let's talk about the economics. That's where the main leadership really excited to know, right? So in our enterprise log pattern, we were using like significantly monthly expenditure for 1 TB of daily logs. Okay, because we have different service integrated. Now, after implementing this model, our current Doris based platform plus compute infrastructure, substantially lower storage on S3, minimal with compression, Lambda enrichment, modest overhead like AI API cost, reasonable with intelligent caching. Other I can say ML inference, efficient with the batch processing, right? So after all this, right, we were spending roughly 20 to 25% of what we were spending before. So that's a 75 to 80% of cost reduction for better functionality, faster queries, and smarter insights, right? And that's when the company says like, what else we can migrate to this architecture? That's when like you have really built something special, right? So that's all started from a single POC, where you can start doing things. But here, what really matters, it's not just about the cost saving. Our mean time to detection improved by 60%. Our mean time to resolution improved by 45%. And our on-call engineers are happier because they spend less time hunting through the logs, like what happened, more time actually fixing the problems, right? So that's the real win: better operations, happier team, and lower cost. And that's the trifecta that we can say, right? So yes, that's the kind of a high level gist of this architecture where we utilize the Doris with the AWS services. Okay, so I'll just jump on to the next architecture here. Great. So I'll keep this shorter because yeah, as for the time constraint. But yes, the now the thing is, like, we call it as a lakehouse intelligence layer, right? We added intelligence everywhere because we integrated the AI within it, and it's really intelligent, right? So picture this: you have built a beautiful data lake on S3. We have petabytes of data, perfectly organized, everything in iceberg or hoodie format, whichever you prefer. Then someone asks, "Can I query like uh, can I query last quarter's sales by region?" So what you will do? You fire up your query engine, you wait, and nearly a minute later, you'll get your answers, right? Which is fine until you realize you need to run this query pattern 500 times a day, right? So we had three options: keep our existing solution and develop patience, right? Copy everything to the warehouse, watch cost explode, and get creative. Get creative is the third option that I would prefer to go with. And we put Apache Doris in front of our S3 data lake as an intelligent caching and the query acceleration layer, right? So how we are doing taking care of this? We have the S3 data lake. From there, we are using the Apache Doris query federation layer, where the smart caching and query acceleration was really getting used in very well. From there, we are using AWS QuickSight. Kind of we have certain REST API Swagger API endpoints that is getting used by the different teams. From there, we have like Amazon Bedrock, like for SQL to text generation, right? Again, for the same explanation I gave in the previous architecture, right? Now, here is the magic. Doris queries S3 directly through external tables. So zero data movement required. But what's smart about it? It catches the frequent access data. It uses S3 to select push down filters and reduce the data scan. Okay. And here's the really cool part, right? So we integrated the AWS Bedrock for AI powered query optimization. It analyzes query patterns and pre-catches the data and predictions we'll need. It's like having a psychic database administrator who will let you know what is going to happen, right? Now, the results, right? So queries that took 45 plus seconds in traditional lakehouse queries, under 4 seconds in Doris, we are not just copying any data until Doris determines it's worth caching, right? So the cost impact was dramatic as well. We eliminated the need of separate data warehouse entirely for this logging purpose or the data warehouse, just intelligent caching on top of our existing data lake. So same data, smarter architecture, way lower cost. That is something we have achieved with this architecture, right? Great. Jumping on to the fifth architecture. Great. So here we have like a data platform with intelligence archival, right? So the cost optimized data platform with intelligence steering. This one's for everyone who ever been told data is an asset and thought, yeah, it's an expensive asset. So here's the reality. You built a data platform, it's beautiful, right? Having everything in the hot tier for maximum performance. Now, 6 months later, you have hundreds of TBs of data. Nobody required 90% of it in months, but you are still paying a hot tire prices for all of it, right? This is the data hoarding problem, right? We keep everything in an expensive storage just in case someone needs it. Most of the time, they don't, right? So we built an intelligence steering system with the three tiers, right? uh, hot tiers, that is for retention for 30 days. We deployed Doris on NVM SSDs for the ultra fast queries because we want it to be lightning fast, right? Now, this is for frequently accessed data. After that, we have the warm tier for 30 to 90 days of retention. Doris with S3 as a storage backend, still fast, dramatically cheaper, greater for occasional accesses. Now we have like cold tier that for the 90 plus days. So we use like S3 Glacier for archival, rarely queried data, minimal cost, but still queryable through Doris external tables. But here's what makes the intelligent rather than just manual tiering. We added like machine learning to predict us access patterns. Okay, again, AI comes into picture because we are now analyzing the access patterns of this data sitting in the S3, or how we can categorize these different layers, right? So the system learns what data gets access together, like seasonal query patterns, user behavior patterns. Then it pre-warms the data before you need it, right? So preload last year's Black Friday data into warm tier. So Black Friday is approaching, right? It's near. So just say like preload the last year's Black Friday data into warm tier. Quarterly board meeting schedule, prefetch last quarter's metrics, something like this. So the system also tracks the query pattern in Doris itself. If cold tier data start getting queried frequently, it automatically promotes it to the warm tier. From warm tier data hasn't been touched in 45 days, it demotes to the cold tier. So yeah, so results, right? 85% reduction in the storage cost, query performance for warm data within 2x of the hot tier prices, cold data queries complete in seconds, not minutes, due to the smart prefetching, zero manual intervention required. It's fully automated, right? So yeah, that's how our storage costs drop dramatically while maintaining the same data access patterns. And when someone does need the archive data from 18 months ago, the system retrieves it, catches it temporarily, and they get their answers. So that's how this isn't a cutting edge AI, it's practical machine learning applied to a real business problem. And the return on investment was immediate, right? So yes, these are all 5 architectures that I implemented. There are many more, but these are something I thought to present here. Finally, the lesson learned and the pitfalls that I want to share here, because I'm here to share the practical insights. Architectures anyone can do based upon the intelligence, but yeah, what are the pitfalls and the lessons that I learned from here? What are the insights from my end, right? So lesson one, compute storage separation isn't always the answer. Okay. So everyone's talking about the decoupled architectures and they are great, right? But not for everything. If your workload is high throughput with consistent load, coupled mode might be more efficient. If your workload is spiky with lot of idle time, definitely decouple it. So we save like 40% on compute by decoupling our analytic workloads, but our real-time ingestion pipeline, we kept the coupled for lower latency. Okay. Lesson two that we have learned is materialized view are powerful but dangerous as well. Materialized view can transform your query performance. Okay. They can also tank your clusters. We created around like 47 materialized view at one point. You know what happened? Our clusters spent like more time refreshing the views than serving the queries, right? So that was a rule of thumb. If a materials view isn't queried at least 10x times more often, then it's updated. You probably don't need it. Be ruthless about deprecating those unused views, right? So that is one of the other thing. Lesson three is like partition strategy matters more than you think. Okay. It's not like just you implement the doorways and you expect the performance out of it. You also need to make sure of the different strategies, the performance optimizations, right? Partition strategy matters more than you think. We once partitioned our user behavior data by user ID. Seemed logical. Queries often filter by users, right? But the result, thousands of tiny partition, 80% of them had less than 1 MB of data. The partition metadata overhead actually hurt the performance. So we need to be wiser while choosing this partition strategies, how we can take care of that. And the other thing is like don't use AI for everything, because in my previous architecture, as you see, I integrated Bedrock and GenAI services. When we first integrated the Bedrock, we tried to use it for every query optimization. Seems smart, right? Wrong. We ended up with a significant AI API cost and the queries that were actually slower due to the API overload. So use AI where it actually add the values. Natural language interfaces where users struggle with the SQL, pattern discovery that human would miss, summarization of the large log volume, semantic search across the unstructured data, right? So that is something. And the final lesson: start with the POC, start small, prove value, and scale fast, right? So find your highest pain, find highest cost problem, build one architecture, demonstrate clear value, and then expand. So that's the thing here, right? So yeah, that is it for here. Now just let's wrap it up for my personal thing. Apache Doris isn't a just database, it's a foundation for building intelligent, cost effective production grade analytics, right? So when you combine it thoughtfully with AWS services and apply AI, it's really good, right? So yes, uh, there's a basic thing before starting on Doris, that a simple POC of, you know, getting the Doris accustomed on the like provision on the AWS, right? So you can start it from my YouTube channel. Just reach out to me, Doris documentation. And as per the time constraint, we are just directly jumping to the question and answers. So let's jump onto it.